Hi everyone, I hope you had a great weekend. Today we're going to talk about section 8-3, which is called graphing quadratic functions. And we did talk about graphing quadratic functions in 8-1. Basically, we just said you choose 5 x values, 2 positives, their opposites, and 0, and you plug those 5 values in to the quadratic function. You figure out what the y values are that correspond with those x values, and then we plotted those 5 points, connected them with the smooth curve with arrows on both ends. That is one way to graph a quadratic. However, there actually is a quicker method using some things that we learned about in section 8-2. And I'm going to show you that now. It's actually like a 4-step method, which may seem like a lot on paper, but once you actually start doing these, it actually is a quicker way of graphing quadratics than working out the function at least a minimum of 5 times. So rather than the table of values, the other way to graph a quadratic is to use the following pieces of information: the vertex, the axis of symmetry, the y-intercept, and then one other point or one other x value that wasn't used already. This one other point works for most of the cases. The only time that you would need 2 other points is if your y-intercept is also the vertex. Then you would need 2 points or 2 x values. And just a quick review from 8-2. Hopefully you remember that the axis of symmetry is the vertical line x equals -b over 2a. And then the vertex would be this x coordinate, and then whatever you get when you plug that x value into the quadratic would be the y coordinate. The y-intercept, if you remember from linear functions, it's the same definition. It's the point where the function crosses the y-axis, or the value of y when x equals 0. When the value of y when x equals 0, when we're talking about a quadratic function, is actually just the c value, because if x is equal to 0, then this would cancel out as well as this, and you're left with just c. So the y-intercept is really just the c value of the function. The function automatically tells you the y-intercept. So the 4 steps, just putting them down on paper. Find the axis of symmetry first using this formula, -b over 2a, and then plug that x value into the given function and solve for y to get the coordinates of the vertex. We're then going to find the y-intercept, which again is just the c value. So you basically just have to look at the quadratic, and whatever c is, that's the y-intercept. And then you're going to find one other point. Again, unless the vertex is the y-intercept, then you have to find 2 other points. And in order to do that, you're just going to pick an x value that's on the same side as the y-intercept. So meaning either on the left side of the parabola or the right side of the parabola. And then basically, since the parabola is symmetrical, it has the axis of symmetry, you can just reflect the points that you graphed on one side over the axis of symmetry to the other. It actually sounds a lot more complicated than it is. So let's do a couple of examples together. The first example is y equals x squared minus 4x minus 5. When we're graphing this one, when we're going to graph this one, the first thing we should do is figure out our a value, which again is 1. If there's no number or coefficient for the x squared, then it's understood to be 1. My b value is -4, and my c value is -5. Again, you always use the signs in front of each term. The axis of symmetry is x equals -b over 2a. So if I plug these values in, it's -4 over 2 times 1, because my a value is 1 and my b value is -4. -4 is actually +4, and 2 times 1 is 2. So my axis of symmetry is actually the line x equals +2, because 4 over 2 reduces to 2. To find the vertex now, you're going to actually plug 2 into the given parabola and solve for the y value. So it would be 2 squared minus 4 times 2 minus 5. 2 squared is 4, minus 8, then minus 5. 4 minus 8 is negative 4, and negative 4 minus 5 is negative 9. So my vertex is at positive 2, comma 9, negative 9. Positive 2 from here, and the negative 9 from here. Again, we said that the y-intercept is just the c value. So if you look at the equation, the c value we said is negative 5, so my intercept is at 0, negative 5. Before I choose my other point, I just want to graph these three things first. So again, we start with the vertex is at 2, negative 9. So 2, negative 9 is all the way down here. That's my vertex. And then the axis of symmetry is basically just this imaginary line going vertically through the vertex. So straight through the vertex. And again, it's an imaginary line. We use a dotted or a dashed line. My y-intercept, we said, is at negative 5. So you're going to put a point at 1, 2, 3, 4, 5, 0, negative 5. And now the other point that I need to choose should be on the same side of the parabola as the y-intercept. So my y-intercept is here. It's to the left of the vertex, which means I need to choose another x value that's to the left of the vertex. You have several, you actually have an infinite amount of options. You could choose, if you wanted to, positive 1. We're not going to choose 0 because that would give us just the y-intercept again. You could choose negative 1 if you want. Let's go ahead and choose negative 1 for now and plug that into the given quadratic. So I have y equals negative 1 squared. Remember, use parentheses if you're plugging in a negative value. Minus 4 times negative 1 minus 5. Negative 1 squared is 1. Negative 4 times negative 1 is actually positive 4, so 1 plus 4 and then minus 5. That becomes 5 minus 5, so my other point, the y value is 0, so it would be negative 1 comma 0. So you can go ahead then and graph negative 1, 0. And then once you have the vertex and 2 points on one side of the parabola, again, this axis of symmetry just makes the points reflectable. So if you look, my purple point is 1, 2, 3 away from the axis of symmetry. So then you're just going to do 1, 2, 3 away in the other direction and put a new point there. And then the y-intercept, the point that I have in red, is 2 away from the axis of symmetry. So I'm just going to continue and go 2 in the opposite direction and put a new point there. And if you look here now, you have the 5 points that you're required to have. You can go ahead and just graph them with a smooth curve and include arrows on both ends. Okay. You don't need to show this part, the reflection part. So you can, if you show it the way that I did, you can erase it when you're finished. And that's our parabola. A few things just to review from 8-2. Again, my vertex is here, and my a value was positive 1, which means that my parabola should be opening up, and it is. And then because my parabola is opening up, that means that the vertex contains the minimum, and it's, again, the x-coordinate of the vertex, which in this case is negative 9. So the minimum value for this parabola is negative 9. And then there are 2, we talked about the zeros of a quadratic, and this is really super important. The zeros, again, are just the x-intercepts. So if you look here, I have 2 x-intercepts. My x-intercepts are at 0, no, I'm sorry, not 0. My x-intercepts are at negative 1 comma 0, and then also 1, 2, 3, 4, 5 comma 0. So that zeros would be negative 1 and positive 5. Okay, let's try one more example together. I have y equals 2x squared plus 6x plus 2. So again, just start by saying, identifying your a, b, and c values. My a value here is positive 2. My b value is positive 6. And my c value is also positive 2. My axis of symmetry is, again, the equation x equals negative b over 2a. So it would be negative 6 over 2 times 2, which is negative 6 over 4, or negative 3 halves. You can leave it in proper fraction. You can make it a mixed number. You can also make it a decimal. Negative 3, I'm going to leave it as negative 3 halves for now to find the vertex, but I'm just going to put the equation is y equals negative 1.5. I am going to, though, to find the vertex, actually use the negative 3/2. So we're going to plug that value into the given function. So y equals 2 times the quantity, negative 3/2 squared, plus 6 times negative 3/2 plus 2. You will have calculators. If we were in class right now, we'd actually be using our graphing calculators. So feel free at home to use, if you have your own graphing calculator, go ahead and use that. If not, you may use calculator on the computer or whatever device you're using. When we work this out, though, it is a good review if you don't have a calculator. Remember your order of operations, do your exponents first. Any whole number you just put over 1. So negative 3/2 squared becomes actually positive 9/4. So we have 2 over 1 times 9/4 plus 6 over 1 times negative 3/2 plus 2. And when you continue to work this out, you end up with 18/4 minus, or 18/4 minus 7 it works out to be, because 18 over 2 is actually 9, so it's negative 9 plus 2, which is minus 7. So when we work this out, we end up with negative 2.5. That means our vertex is at negative 1.5, comma, negative 2.5. And then to find my y-intercept, again, it's just the c value. So we already know that c is equal to 2, so my y-intercept is at 0, comma 2. We're going to start by doing all of this, plotting all of these things first. I'm just going to rewrite it on the next slide so I can fit the actual graph. Our axis of symmetry is at x equals negative 1.5. Our vertex was at negative 1.5, comma, negative 2.5. And our y-intercept was at 0, comma 2. So if we go ahead and plot those things, 0, 2, I'll start with, since I'm using red already, is here. My vertex is negative 1.5, negative 2.5. So that's 1.5 to the left and then 2.5 down. So it's actually kind of in the middle of this box here. And then again, the axis of symmetry is just basically a straight line, a dashed or dotted line through that green vertex. If you notice, the y-intercept, the red point here, is to the right of the vertex. So I'm going to choose another point to the right of the vertex. Again, you have an infinite amount of options. You could choose any fraction, decimal, rational number, real number that is to the right of it. So you could choose, if you want, negative 1. You could choose positive 1. You could choose 16 if you wanted to. That would give you a really large number, so I don't recommend that. I'm actually going to choose positive 1. So let's just go back to the previous slide and plug that information in. If I choose positive 1 and solve for y, it's y equals 2 times 1 squared plus 6 times 1 plus 2. So 2 times 1 squared is just 2, plus 6 times 1 is 6, plus 2, so it would be 10. So that means the point is at 1, comma 10. So my other point is at 110, so you can go ahead and plot that. It's all the way at the top. And then again, remember, a parabola is symmetrical. So if you look, this red y-intercept is 1.5 away from the axis of symmetry. So then you're going to go 1.5 away in the other direction and put a new point. And then same thing, the yellow point up here all the way at the top is actually 1, 2.5 away. So you're just going to do the half and then 1, 2 in the other direction so that it's symmetrical. Put a new point there. And again, you're going to do your best to use a smooth curve. That's pretty crooked. Try your best to make it as smooth as possible. Arrows should be on both sides. And again, just a quick review. Our A value was positive 2. So that means the parabola should be opening up, and it does. Because it opens up, that means the vertex contains the minimum. So the minimum value here is negative 2.5, because again, there could be nothing below this y equals negative 2.5. It's not possible. And then the zeros, you could estimate from the graph. There's definitely 2 zeros this parabola has, but you would have to check it algebraically, basically, to make sure that you're using the right coordinates. So that's how you graph quadratic functions, using axis of symmetry, vertex, y-intercept, and then just reflecting. Again, it does, in the beginning, it seems like a lot, but it really is a faster way to graph quadratics than picking 5 random numbers, plugging them in, and solving every time. I'm going to have you guys do some problems from your workbook. So if you didn't bring your workbook home, you can access it on my HRW. It's the practice page for 8-3. I'll also post the PDF of it for you. I do recommend either printing it or printing graph paper if you don't have graph paper, because without graph paper, this is obviously a very tedious task. And I will also have you practice graphing on the computer at some point this week. Okay, if you have any questions, please just let me know. Have a great day, guys.